Good day, students. Today, I want to solve problem on homogeneous differential equation, part 3. A very simple uh, question, but you have to follow some rules. One of the things you have to know is that in the equation given, you have to substitute y to be equal to vx. After that, you must differentiate what you substitute with respect to x. That means you must have the y over dx equals to v plus x dv dx. I'll show you how to get it using product rule. After doing that, what you differentiated in the y dx, you equate it to the y dx in the equation given. But before then, you must substitute your y equals to vx anywhere you see y. Okay, what I'm saying is that once I substitute y equals to vx in dy over dx equals 2xy plus 3y squared over x squared plus 2xy. Let's do the substitution before differentiating y equals to vx using product rule. And always have it at the back of your mind. Don't forget that when you are dealing with homogeneous equation, you must substitute y equals to vx. Now let's continue. Let's do our substitution. dy over dx equals 2x multiplied by vx. I'm substituting it now, plus 3 vx in bracket squared over x squared plus 2x multiplied by vx. Now have 2x squared v plus 3v squared x squared over x squared plus 2x squared v. Now let's factorize what is common out. We're having x squared here. Now having x squared bracket 2v plus 3v squared over x squared open bracket 1 plus 2v. X squared cancel x squared. We're left with dy over dx equals 2v plus 3v squared over 1 plus 2v. Let's call this one equation 1. And let's go to y, expression y equals vx, what we substituted. Now using product rule, you say using product rule, differentiate y equals vx. When you differentiate that, you're having dy over dx. You keep the first one and differentiate x, v dx over dx plus cube dx and differentiate v dv over dx. Now when you differentiate x, you have 1 v into 1 plus x dv over dx, which is equals to v times 1, that's v, plus x dv over dx. Let's call this one equation 2, or that equation 2. Now, what you need to do now is that you have to equate the two together. Since you're having dy dx to be v plus x dv dx, you now equate it with what you have in equation 1, but they are both dy over dx. But before then, let me show you how we got 1, and also the reason why we did not write dv over dx as 1. There's no guarantee that dv over dx equals 1, because v may change at any rate with respect to x. At any rate, there's no guarantee that dv over dx is 1. This v is a function of x. X is independent, while v is dependent. Okay? Dependent, there's no guarantee that dv over dx is equal to 1, because v will change at any rate with respect to x. But under x itself is a fixed guarantee, has a fixed guarantee. X itself has a fixed guarantee. That's why when you differentiate x, it will be 1. Okay, as a fixed guarantee. Let me show you. You're having y to be ax raised to power n. Let's differentiate dy over dx equals a dot n x raised to power n minus 1. Now let's now have y equals to x, dy over dx equals 1, there's 1 here, times the power, there's 1 there, times 1, 1 minus 1, equals 1 times 1, 1, x raised to power, multiplied by x raised to power is 0, x raised to 0 is 1, 1 times 1 equals 1. Okay, that's how we got 1 here. Now when I equate the two, now let's equate the two. Equate equation 1 and equation 2. We're equating them because they are both expressed as dy over dx. Now v plus x dv over dx equals 2v plus 3v squared over 1 plus 2v. Take v to the other side. Now having x dv over dx equals 2v plus 3v squared over 1 plus 2v minus v over 1 equals to what the LCM. This is 1 plus 2v. 1 plus 2v and 1 plus 2v is 1 times 2v plus 3v squared. We're having 2v plus 3v squared minus 1 in 1 plus 2v. We're having minus v multiplied by 1 plus 2v. From there, you're having x dv over dx equals 2v plus 3v squared. Let's open the bracket, minus v times 1, that's minus v times 2v, that's minus 2v squared over 1 plus 2v. Now let's collect the like terms. We're having 2v minus v plus 3v squared minus 2v squared over 1 plus 2v. 1 plus 2v. 2v minus v, that's v, plus 3v squared minus 2v squared, that's v squared over 1 plus 2v. Okay, now what you need to do is I want to make it to be in terms of v and x so that you can integrate them. Now x dv over dx equals v plus v squared over 1 plus 2v. From here, let's cross multiply so that x can be on one side and v can be on another side. Now cross multiply. When you do that, you're having x dv, x, let's write it like this, x 1 plus 2v dv. X multiply 1 times 1 plus 2v, let's say be in the bracket, dv equals v plus v squared dx. Okay, want this v plus v squared to come to this side because 1 plus 2v, open bracket and close the v, they are in the v. Now divide both sides by v plus v squared. This side also v plus v squared. Whatever you do to the right hand side, you do same thing to the left hand side. Cancel out. Now x to bracket 1 plus 2v dv over v plus v squared equals to dx. Now divide both sides by x. Divide both sides by x. Divide both sides by x. You now have x 1 plus 2v dv over v plus v squared equals dx over x divided by x. X cancel x. You're left with 1 plus 2v dv over v plus v squared equals 1 over x dx. Now say integrate both sides. Now since we have v on one side and x on another side, can I integrate both sides? Integral of 1 plus 2v over v plus v squared dv equals integral of 1 over x dx. Now, you can now ln of v plus v squared give us what you have at the numerator. Ln v plus v squared equals ln x plus c. Okay, now let c equals ln a. Since everything is in ln, let's replace c to be ln a. Ln v plus v squared equals ln x plus ln a. When we are dealing with addition under indices is products and they are both ln, can I write ln v plus v squared equals, let's represent with one ln ax. Ln ax. Okay, from here ln cancel ln. Ln cancel ln, you are left with v plus v squared equals to ax. And then forget that from y equals to vx, let's make v the subject of the formula so that you can replace our expression with replace our expression so that it will be in terms of y and x. Now v equals y over x. Now y, substitute, let's call it this one equation 3. Substitute v equals to y over x in equation 3. Now I have y over x plus y over x squared, because v is squared here, equals to ax. Now y over x plus y squared over x squared equals to ax. Find the LCM. LCM is x squared. X in x squared is x, that's xy. So cancel one of the x, you now use the other x to multiply the numerator, xy, plus x squared in x squared, that's 1. 1 times y squared, that's y squared, equals ax. Now you cross multiply. Cross multiply. When you do that, when you do your cross multiplication, now xy plus y squared equals ax times x squared. Xy plus y squared equals we're having x here, put under x squared, that's ax raised to the power 3. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.